In this example, we're going to look at how in just a few minutes Carbon Mixer allows you to calculate the financial benefits of the UK feed-in tariff on various renewable energy choices for your building development. I've opened a new project. We're going to use items from the built-in database throughout, though you could create your own specification of wind turbines, photovoltaic panels and buildings in the Carbon Mixer database if you preferred. So I'm going to add a building to give us some demands. I'm going to choose an office from the database. Let's go for a naturally ventilated office, and I'm going to specify 1,000 square meters of that. So straight away that's given us some demands. They're being met by a boiler, electricity from the grid, and that's resulting in some carbon dioxide emissions for heating and electrical appliances. So we'll use that as a base case, but now I'm going to add a scenario. I'm going to call this one wind turbine. Initially this is an identical copy, so let's add a wind turbine to this second scenario. I'm going to choose one from the database. Let's choose the largest one that's appropriate in an urban environment. That's a 9-metre diameter turbine, and we're assuming 5.5 meters per second wind speed, which is very good, about the best you could possibly expect in an urban environment. So we'll add that one, and straight away we can see that's given us a 32% reduction in CO2 emissions for a £40,000 investment. If we go to the fuel use tab, we can see a number of tables. I'll just expand that a little so we can see a bit more detail. The top one is a breakdown of what the fuel, how the fuel is used. The middle one is more detail on what systems are using them. But the one I'm interested in is the one at the bottom. I'll get rid of those two, which is the one that gives details of the feed-in tariff. Just shrink that back again. So it's showing us that our wind turbine here, we're generating an income of £9,000 per year for the production of 33 megawatt hours of energy from our 15 kilowatt turbine. And I'll just zoom in a little so we get another decimal place, and there we can see that we're getting 27 pence for every kilowatt hour of energy that we produce. So I'll go back to the comparisons. I'm going to generate another scenario, start off the same as the base case again, and I'm going to call this one photovoltaic array. So initially that's the same as the base case. Let's add some photovoltaics, some PVs. I'm going to add 70 square meters of a fairly optimally placed photovoltaic array. Assume that that's reasonable for our site. And we can see that's given us a 7% reduction in CO2 emissions for a £45,000 investment. So if you are lucky enough to have a very windy site that you can put turbines up, that's obviously the way to go. But let's study the PV array in a bit more detail. We'll look at the fuel use feed-in tariff table again. We can see we're getting just under £3,000 or £2,700 per annum for that. And we're getting a tariff here of 36 pence per kilowatt hour. What I'm going to do now is I'm going to double the size of the array. I'm going to add another 70 square meters, so it's twice as big. And if we look at this table now, we see that the power has gone up. The size of the array is now nearly 18 kilowatts. Our generation tariff has actually dropped from 36 pence per kilowatt hour to 31 pence per kilowatt hour. That's because if you have an array larger than 10 kilowatts, you get a smaller tariff. There's higher incentives for more smaller photovoltaic arrays. Going back to the comparisons, I'm going to generate another scenario, this time based on the scenario we're looking at, the PV array scenario. So this will initially take a copy of it. I'm going to call this one PV2 arrays. And we can see we've got the same CO2 reduction, it's identical for now. I'm going to add a payback graph as well. That's showing an 11-year payback in these cases. What I'm now going to do is change the name, so we've got different names for the two halves of this array. Call it PV array 1 and PV array 2. Now this has improved our payback. It's gone from 11 years down to 10 years. If we go back to the fuel use table, we can see why this is. Carbon mixer, because we've given it two different names, it's now interpreting it as two different arrays rather than two halves of one large array. And because each of these arrays is less than 10 kilowatts, we're now back up to the 36p tariff, and so overall we will get more income out of it. The rules for when you can classify an array as one large one or as two small ones are covered in the feed-in tariff, so you'll need to make sure that you're following those, but this just shows how you can implement it in Carbon Mixer. Now let's go back to looking at the single PV array, and I'm going to demonstrate something here by reducing the load of both of these from 100% to 50%. What the load means in this context is the amount of the energy produced that will get used by the demands on the site. So we were using 100% on the site, but now we're only using 50% on the site. The other 50% will then be exported to the grid, and we can see in the feed-in tariff table we're getting £220 per annum for exporting to the grid. So this sounds like it's more money. However, when we look at the comparisons, we see the payback in this case has gone from 11 years to 13 years, so things have actually got worse. This is because electricity exported to the grid, you only get paid 3p per kilowatt hour for that electricity, whereas any electricity you save by using locally, you're saving 10p per kilowatt hour. So it's better if you can use it than if you have to export it. The usual assumption is that you will be exporting 50% because you'll be generating electricity at times of the day when you can't use it. For example, if it were a wind turbine in the middle of the night, or a PV system, perhaps a domestic one in the middle of the day when people are out. I'm going to explain this in a bit more detail by looking at the current scenario tab. I'm interested in the energy balance here, so I'm going to get rid of the CO2 graph and zoom in on this one a little. I'll just expand it, make it a bit wider as well, so it's easy to see what's going on. And I'm going to illustrate this. I'm going to go back to the wind turbine example, and I'll just explain this graph for a moment. Below the line we see the energy demands. They're treated as negative energy, or energy that we are withdrawing from our energy account. And we can see that we've got demands for heating and for electrical appliances. Meeting those demands, in the blue above the line, we've got gas boilers providing the heating. In grey we've got electricity from the grid for the appliances, and in the cream we've got the wind turbine generating its energy which we're using locally. If I now change the load on the wind turbine from 100% to 50%, so that we only use 50% on site, you will see, there we go, that now 50% of that wind turbine energy is being exported to the grid, but that's meant that the grey import from the grid has had to increase for when we need that energy. We're getting 3p per kilowatt hour for what we export, but we're paying 10p for electricity that we need. So hopefully that makes it clearer why it's better to use the energy on site if you can. I'm going to put that load back to 100%. I just want to show that it's not always possible to use all of the energy. For example, if we had 2 wind turbines rather than 1, you can see now that there's a large amount of electricity generated, in fact more than we can use, because the cream blocks here more than balance the yellow demands at the bottom. Therefore, we're being forced to export to the grid. So even though we've asked for 100% to be used on the site, if that's not possible because the demand isn't there, Carbon Mixer will automatically export it in any case. If we go back to the fuel use table, we can see that we're getting some income there for the grid export of the energy that we can't use, even though we're attempting to use 100% on site. Let's go back to the comparison graph there. We can see the different scenarios we've looked at have paybacks from 3 years to 13 years. To see the effect of the feed-in tariff, that's through a combination of saving electricity, not having to get electricity from the grid in the first place, but also being paid to produce it. To see the effect of that, we can turn the feed-in tariff off. So let's go from, instead of having the feed-in tariff incentive, we'll have no incentive. And there we see that payback jumps up from being between 7 and 41 years rather than 3 and 13. I'll turn it back on. So clearly the feed-in tariff has quite a big effect. We can see all of that summarised. There's a feed-in tariff report. I'll just fire that up. And all of the information we've been looking at so far is summarised in this report. I'll just page down. It's all there. And we'll just focus in on this summary table here, and you can see this is giving all the details we were looking at for the incomes for the different scenarios, and they're summarised in graphs below. Finally, we'd save the project so it's easy to come back to and see what assumptions we made. Or of course it can be passed on to a colleague or emailed to a client for them to review and see exactly what your thinking was. As you've seen, the Carbon Mixer feed-in tariff calculation happens automatically, so there's no expertise required to implement it. The results are totally open, so it's easy to see why different options have a different effect on the payback of your energy systems.